Welcome to the second summary episode of the book Cloud Native Transformation Practical Patterns for Innovation. My name is Luis Ariza, and today I will start about what is cloud native and cloud computing. Also, I will explain the inherent complexity when a company starts the cloud native transformation. Additionally, I will speak about the five architectural principles of the cloud native infrastructure. They are containerization, dynamic management, microservices, automation, and orchestration. Finally, it's important to mention two cultural principles, and they are delegation and dynamic strategy. All principles together that I mentioned before help directors and CEOs, people who make big decisions in the company, to implement a successfully cloud native infrastructure. What is it, cloud native and cloud computing? First of all, we must talk about cloud computing, often referred to simple as the cloud. Cloud computing is the on-demand delivery of infrastructure, in this case, hardware of or servers, storage, databases, and all kind of application services via the internet. The companies that offer those application services are typically called hyperscalers. For example, we have Azure, Amazon Web Services, Google Cloud, IBM Cloud, Alibaba Cloud, Red Hat Cloud, Cloudways, Linode, DigitalOcean, Rackspace, and Cloudflare. Secondly, cloud native is a complete architecture, a philosophical approach to build applications taking advantage of cloud computing. So cloud native takes all the components to optimize the cloud environment. Cloud native is about services, not servers. It is important to have clear this idea. Cloud native is also an organizational destination for companies that are looking to modernize their infrastructure and process and even the organization culture. Probably in short time, the cloud native paradigm will completely change the way we implement applications today. What is cloud native and what isn't? We need to be clear that identifying, provisioning, and then deploying the just right combination of services to best take advantage of this new, rapidly evolving world among the clouds can take very different forms depending on the needs of a particular organization. In the image, you can see two directors who decided to do the cloud native transformation for their company. The first one implemented the cloud native in 3 months, and the second one in 3 years. The first one director took all the services and solutions given by the hyperscaler, and the second one took the time to know the new technology, test some application for deploying the cloud native infrastructure, analyze the advantage and disadvantage of private and public clouds, and adjust the application for its company. Here, I need to mention that any journey to cloud native takes time. It's complex and difficult. It's easy to get lost. Enterprises ready to undertake their own cloud migration, staying on track, means focusing on the architecture, understanding and prioritizing design before jumping into full-on implementation and deployment. Now developing a cloud-native pattern language is the next step in drawing a useful and a reuseful roadmap. A shared language for identifying common contexts and discussing tools, techniques, and methods is essential for developers to be able to discuss, learn, and apply the best practices in cloud native, even as they continue emerging. This information is based on the observation and the experience, and is the best option to do a cloud native transformation, avoiding the same mistakes every time a company needs a migration. The idea of how many application companies can use To implement the cloud native transformation, I put the Cloud Native Computers Foundation CNCF landscape. So each company could select one or another application based on the company needs. The applications are grouped by tasks such as provisioning, runtime, orchestration and management, application definition and development, and more. The CNCF is the entity that oversees and coordinates the emergence of open source technology that supports cloud native software development. The CNCF emphasizes open source technologies, but there are also important cloud native tools offered by commercial providers. Essentially, cloud native is the name of a particular approach to designing, building, and running a computer application as services that are packaged into its own container and dynamically orchestrated those containers to optimize resource utilization. The architecture rests upon infrastructure as a service combined with new operational tools and services like continuous integration, container engines, and orchestration. The objective usually is to improve speed. Companies of all sizes now see a strategic advantage in being able to move quickly and get to market fast, putting a new idea into production within days and or even hours instead of months or years. How do I know cloud native when I see it? First, I need to explain each principle. So we have two groups, the architectural principles and the cultural principles. The first one of the architectural principle is the containerization, that is, encapsulate application together with their dependencies, operating environment, and all in a single package. This makes them easy to test, move, and deploy. The second one is the dynamic management, using cloud-based servers that can be flexibly provisioned on demand. If on a public cloud, which is typically companies pay on for resources when they are actually used. The third one is microservices. Design an application as a collection of small decoupled component services. Each microservice can be deployed, upgraded, scaled, and restarted independent of other services in the application and with no impact on the other user. Microservices increase velocity by allowing teams to develop in parallel, working on their components simultaneously yet independently, thanks to the elimination of dependencies and the coordination efforts that come with them. I continue with the automation, replacing manual tasks like maintenance and updating with the scripts or code. The last one is the orchestration, that is tying it all together by automating the deployment, scaling, and management of containerized application, specifically using container Kubernetes or another orchestration tool to control and automate tasks such as availability, provisioning, and deployment of containers, load balancing, and containers across infrastructure, and scaling up down by adding removing containers as needed. I continue with the cultural principle. The first one is the delegation. Offer individuals the tools, training, and discretion they need to safely make changes, then deploying and monitoring them as autonomously as possible. The last one is dynamic strategy, that is communicating a strategy to teams but allowing them to modify that strategy in response to the results. That is the ultimate purposes of fast experimental deployment that Cloud Native provides. There is no point running experiment if you don't make use of what you learn. So when you see an application built and deployed in a rapid iteration by independence, compact feature development teams, and those teams are collaborating together via an integrated platform that decouples infrastructure while providing automated monitoring and testing. That is when you know you are looking at the cloud native approach in action. Cloud native architecture also allows us to create complex systems by dividing them into smaller components built by independent teams. This differs from traditional monolithic application complexity, which is limited by the ability of the developers and architects to fully understand its even it even as it chains them together to deliver in unison. Finally, cloud native is about how we create and deliver, not where we do that. How do I know cloud native when I see it? First, cloud native is about how we create and deliver, not where I do that. Second, an application built and deployed in rapid iterations. Third, a group of independent teams. Fourth, collaboration between teams via an integrated platform. Fifth, the coupling of infrastructure and providing monitoring and testing. And the last one, there is no monolithic applications. So we need to differentiate between monolithic, as we see here in the left part. If something is wrong, the whole application doesn't work. In the right part, the monolithic or the whole application called monolithic is separated between microservices. In a cloud native infrastructure, this problem of the previous problem is solved. So we can reduce the risk in a new way, going fast and small and limiting the blast radius if, for example, some microservices doesn't work. If one of them doesn't work, it can instantly be replaced or rolling back. So how do I fit everything together? So if you see in this picture, in the center of that picture, you see microservices. So in order to be able to run microservices successfully, we need to be master in containers, dynamic management, automation, and orchestration. So there is a solution in order to buy the infrastructure. We can hire infrastructure, for example, from hyperscaler. This is called infrastructure as a service. Also, we can manage and maintain all that virtualized infrastructure like a platform as a service. And finally, we also can pick and choose component application using virtual infrastructure management tools, in this case called software as a service. In the future, hyperscalers will offer functions as a service as well. And this is the future of the cloud native. So, what could possibly go wrong? So, companies, when they start the cloud native transformations, they may fall inside these three problems. The first one is difficulties due to the complexity of distributed systems. The second one is the relative immaturity of the cloud native ecosystem with this wild west landscape of tools and platforms. Do you remember the CNCF landscape? So this is one approach of the problem engineers must face when they start this implementation. And the last one is the failure to adapt and evolve organizational culture to keep pace with changing technologies and delivery expectations. We live in a highly mobile world where applications get accessed and used across a bunch of platforms and devices. Users expect a fast, seamless, and always on experience. For example, in a Cyber Monday or a Black Friday, we don't want to be in a waiting list. To fulfill these expectations and keep the user happy, we use distributed systems to manage the inevitable fluctuations and failures of the complex behind the scenes services required to run it all. A simple way to think about distributed system is a multiple independent functions all together to present to the end user as a single unified experience. The primary benefit of a distributed system is reliability. When computing processes are spread across an entire network and machines, they happen independently from each other. If one fails, the process still keeps going. The side effects of these benefits are called complexity, and the design, construction, and debugging of the cloud native platforms all get much harder. A failure is inevitable, and engineering teams need to have contingency plans so that the end users hardly notice when it does happen. The tools and knowledge necessary to detect those failures points are advanced, and now a few companies in the world have the ability to do this for themselves. So, public cloud platforms or hyperscalers like Amazon Web Services and Azure are presented as full end-to-end solutions, but they are far from to plug and play. The CNCF landscape I present to you before shows more than 1,200 technologies, vendors, and projects to choose from when mapping a cloud migration, and they continue growing. So even though small companies can achieve cloud native transformation as big ones, it requires a lot of time and maturation. This journey is not as simple as we would think.